We continue our Flutter for Beginners series. In this video, we have Write Your First Flutter App, Part 1. This is a guide to creating your first Flutter app. If you're familiar with object-oriented programming, object-oriented code, and the basic programming concepts such as variables, loops, and conditionals, you can complete this tutorial. You don't need previous experience with Dart, mobile, or web programming. This codelab is part 1 of a 2-part codelab. We will do the second part of the codelab in another video. Here is the end product we hope to see today at the end of this video. What you'll learn in part 1, how to write a Flutter app that looks natural on iOS and Android and the web, basic structure of a Flutter app, finding and using packages to extend functionality. That involves using the import statement as well as the pub spec file, using hot reload for a quicker development cycle, how to implement a stateful widget, how to create an infinite lazily loaded list. This tells us what you need to use. This tells us how to web enable and allow us not only to run it on a mobile simulator or on a real mobile phone, you can run it in a browser. So let's get right to it. Let's take a copy of this sample code, place it in this case Android Studio. I'll start up the emulator while we're here. When we run this, it'll demonstrate that it'll run fine on an Android phone as well as an iOS phone. This example creates a material app. Material is a visual design language that is standard on the mobile and the web. Flutter offers a rich set of material widgets. The main function uses the arrow notation. Use arrow notations on one-line functions or methods. The app extends a stateless widget, which makes the app itself a widget. In Flutter, almost everything is a widget, including alignment, padding, and layout. The scaffold widget from the material library provides a default app bar, title, and a body property that holds the widget tree for the home screen. The widget subtree can be quite complex. The widget subtree is made up of other widgets calling widgets. The widget's main job is to provide a build method that describes how to display the widget in the terms of other lower level widgets, in the terms that build function is going to have other widgets. The body of this example consists of a center widget containing a text child widget. The center widget aligns its widget subtree to the center of the screen. It aligns its child widgets to the center of the screen. Now that we have this open, let's run it. Take a little while because it's being compiled for the first time. We'll examine this quickly. We're importing the material library. If I right click on this, let's take a look. It's a common practice when you import one library file from a library. That one library file, in fact, exports the vast majority of the content of that library in a series of export statements. You can see there's a lot that makes up that particular library. the run app function. it's usually the start. Dart, in fact, looks for a function called main. As you can see, this too is just a one-line statement, hence we can use the arrow notation. Let's look at the run app. It itself is a function. It says here, inflate a given widget and attach it to the screen. Inflate a given widget and attach it to the screen. The widget is given constraints during layout that forces it to fill the entire screen. If you wish to align your widget to one side of the screen, consider using the align widget. If you wish to center your widget, you can also use the center widget. It accepts a widget. So, as it happens, stateless widget is itself extends a widget. And in there, we have to fill in its build function. So we've already built that. I want to look at the build function. So we scroll through here. It's protected. In other words, the only way you can access it is if you extend the class, create a subclass. Describes the part of the user interface representing that widget. The framework calls this method when the widget is inserted into the tree at a given build context and when the dependencies of this widget change. For example, when the inherent widget referenced by this widget changes. The framework replaces the subtree below this widget with the widget returned by this method, either by updating the existing subtree or by removing the subtree and inflating a new subtree, depending on whether the widget returned by this method can update the root of the existing subtree as determined by calling widget can update. The subtree that they speak of is all the children widgets produced within the build function. Typical implementations return a newly created constellation of widgets that can be configured with the information from this widget's constructor from the given build context. The given build context contains information about the location of the tree at which this widget is being built. For example, the context provides the set of inherited widgets for this location in the tree. A given widget might be built with the multiple different build context arguments over time if the widget is moved around the tree or if the widget is inserted into the tree in multiple places at once. The implementation of this method must only depend on the fields of the widget, which themselves must not change over time, and ambient state obtained from the context. If the widget's build method is to depend on anything else, use the stateful widget instead. In other words, the stateful widget will allow the state object to retain in resident memory, while the stateful portion, the stateful widget itself, that class, will be inserted and reinserted throughout the tree. So in this build, we have the material app found in the library. It contains a number. As you know, to possibly know that in Flutter there are hundreds. There are many, many parameters involved in most of the widgets. So this material app, in this case, we utilize the title, home, and the home parameter is simply a widget. We run this. It simply produces that hello world. From our previous video, I'm just simply going to copy now the style. That hello world is far too small for my tastes. So I'm going to copy that, go back to it here, paste in an additional parameter, like so. Control R, reformat code with Dart format, makes it nice and clean. So now this state widget has, of course, its required first string parameter, and then it has the named parameter called style, and it takes in a class object text style. The moment I save this, hello world is going to get a little bigger. Save that, and there we go. Let's read on here. Use an external package. In this step, you'll start using an open source package named English Words, which contains a few thousand of the most used English words plus some utility functions. You can find the English Words package, as well as many other open source packages, on pub.dev. If I quickly click on that, you can quickly look at my my contribution so far. I have a number of packages myself for this humble community. Let's go back. So, step 2. Of the most used English words plus some utility functions. The pub-spec file manages the assets and dependencies of the Flutter app. In the pub-spec, add English words to the dependency list. So we'll do just that. I'm going to grab this. Look at that. It utilizes the GitHub screenshot showing the differences. So in this pub-spec, the green line indicates a new line is inserted right after the Cupertino icons. So let's do that. I'm going to go now to the pub-spec file. As it happens, I've already put it in there. You notice I always put in the trailing zeros. This is the major version number, minor version number, and this is the patch number. This is semantic versioning, where the trailing number specifies any bug fixes. The minor number indicates that there's new functions and features, not necessarily incompatible with previous version. So it still retains backward compatibility, while the major version number indicates that there was a major release and unlikely to be backward compatible. So putting these two in 0 allows any upcoming errors to be fixed and any new functions and features to be brought in. I don't like fixing it myself too. In this case, for example, I would set that to 0. Every time I do a pub upgrade, then any errors, whatever may be with icons, will be brought in. So I'm going to save that. Get dependencies. It does just that. So let's go. I suspect now we have to import it. We certainly do. So now in the main project, we go here, highlight that, paste this in, and we have ourselves a new library imported into the IDE, into Android Studio. As you can see, it's grayed out at the time. That's telling us the IDE is indicating to us that there's no functions or features being used from that library at this point. But that will soon change. Step 4 here, 4. Okay. As you type, Android Studio gives you suggestions for libraries to import. It then renders the import string in gray, letting you know that the import library is unused so far. Let's see, giving you suggestions. Let's just quickly demonstrate that. So as I type, as you can see, it's offering. It's trying to offer you other libraries, quite frankly, that you likely use. Sure enough, it even lists, because we already have that library in the pub spec, it knows to offer that in the listing. Okay, let's continue. Okay, so again, in this GitHub diff screenshot, the green lines tell you we're inserting new information. The red line indicates we're deleting. So within the build function of that stateless widget, we're introducing a new variable coming from that library, English words. And it's obviously an object. It's a static property. It's a static function in this case called random. And then they take that value. It's possibly a getter when I then call as Pascal case. Copy that. Right. Go here. Insert that in there. Stateless widgets are immutable, so it's encouraged to make even the variables within a function immutable. I could just have, this is just as legal. I'm going to first put in the other line just to make this more feasible. Okay, so I can go here. All right, you know what I'm going to do? I want to preserve that text style, so I'm just going to grab the contents thereof. I'm going to replace this string with a getter. Nice. Now that word pair variable is no longer gray, it's being used. And this, as you can see, the compiler is not complaining. It's within a function. So it could be a variable. It could be a variable that changes over time. In fact, it could be a word pair, of type word pair. It still won't complain. But again, they like the fact that everything within this class is immutable. Everything doesn't change. So what does this do? Random. Creates a single word pair randomly. Or I save that. Let's look at this. So in the text widget now we have something from word pair. It is a getter. Returns the word pair as a single string with each word capitalized, formerly called Pascal case. Pascal case means that you'll have a variable, memory variable, for example. I suspect they describe it here. Pascal case, also known as the upper camel case, means that each word in the string, including the first one, begins with an uppercase letter. So yes, upper camel case would be changed to this, upper camel case. Now, I want to quickly see what this does. We look at this getter. It returns a string. It has an instance variable that's private, library privates within this Dart file called word pair. This null if null assign operator. If this is null, then create a word pair that's in Pascal camel case as they call it. Let's take a look here. So it grabs it has additional instant variables. One's the first and second, so that's the word pair. It has capitalize in it. Oh, here we go. Capitalize again. It takes in a string. The first character of that string is set to uppercase, and then the substring starting at the second character is all lowercase. That's pretty good. So we run this. So we'll run this now. Reload. Look at that. There we go. Bright pen. Let's read on. If the app is running, hot reload to update the running app. Each time you click on hot reload or save the project, you should see a different word pair chosen at random in the running app. This is because the word pairing is generated inside the build method, which is run each time the material app requires re-rendering, and when toggling the platform in Flutter Inspector. So let's go back here for a moment. How about if I just hit that lightning bolt in my Android Studio, and we should get a different slight law. Let's continue on with this. If you have problems, they of course provide you with the source code right then and there. Keep getting along here on this web page. Add a stateful widget. Stateless widgets are immutable, meaning that their properties can't change. All values are final. Stateful widgets maintain state that might change during the lifetime of the widget. Implementing a stateful widget requires at least two classes. A stateful class that creates an instance of, number two, a state class. The stateful class is itself immutable and can be thrown away and regenerated, which it is, by the way, time and time again, every time you rebuild. But the state class persists over the lifetime of the widget. In this step, we'll add a stateful widget random words, which creates its state class, random word state. You'll then use random words as a child inside the existing MyApp stateless widget. Create the boilerplate code for the stateful widget. In the main library, position your cursor after all the code. Enter return a couple of times to start on a fresh line. In your IDE, start typing Stateful. That's right. The editor will then just produce the whole class for you. Saves on typing. The editor asks if you want to create a stateful widget. Press enter to accept. The boilerplate code for the two classes appears, and the cursor is positioned so you can enter the name of the stateful widget. Give that a go. Put this one side. Again, the wonderful thing about Dart, you can put any number of classes in a library file, any number of high-level variables. Oh, look at that. It even brings it up. A new stateful widget. I'm going to highlight that, double click. Sure enough, it comes up. And we are to type in random words. And it even fills in everything for you. Random words. Now I notice here again, create state returns a state. It doesn't necessarily have to be the name. That's legal right there. That's just as fine. That worked just as well. And so again, good practice for the state object to be library private. No one else needs to know the name of the state object. Of course, everyone, by convention, it's simply the name of the stateful widget with the word state appended on the end in Pascal case. Okay, let's continue. Enter random words as the name of your widget. The random words widget does little else besides creating the state class. Once you've entered random words as the name of the stateful widget, the IDE automatically updates the accompanying state class, naming it random words state. By default, the name of the state class is prefixing with an underbar. That should say underscore. Prefixing an identifier with the underscore enforces privacy in the Dart language and is recommended best practice for state objects. The IDE always automatically updates the state class to extend state random words, indicating that you're using a genetic state class specialized for use with random words. That means that allows you then to have access to any of the instant properties, instant variables that make up the stateful widget random words. Most of the app's logic resides here in the state object. It maintains the state of the random words widget. The class saves the list of generated word pairs, which grows infinitely as the user scrolls. And in part 2 of this lab, favorite word pairs as the user adds or removes them from the list by toggling the heart icon. Something to look forward to. Both classes now look as follows. Yeah. And then we do this. Update the build method in random word state. So I'll just copy that and replace the whole class. And it's taking in that word pair that we conceived, as well as text widget will take in the Pascal case. Okay. So let's just highlight the whole thing. Paste it in. There we go. It says here, after adding the state class, the IDE complains that the class is missing a build function. Next, you'll add a basic build method that generates the word pairs by moving the word generation code from my app to random word state. Maybe this doesn't. Remove the word generator code from my app by making the changes below, shown in the difference below. Okay. So in other words, in red now, get rid of that line, and simply put in random words. Okay, I can do that. So these two lines now being removed are in, you know what I'm going to do, of course, right? I want to save that text type. So I go like that, copy that, go back to here, look, go back to the random state, put that in there. Then I'm going to take random words here, that call, go like so, done. Right click, reformat. If I hit save now, let's go here, nothing's changed. Everything's changed under the hood. So now, we continue on. Restart the app. The app should behave as before, displaying a word pairing each time you hot reload or save the app. Okay. If there's any problems, of course, they provide you with the code themselves. Step 4, creating an infinite scrolling list view. In this step, you'll expand the random word state to generate and display a list of word pairing. As the user scrolls a list, displayed in a list view widget, grows infinitely. Okay, well the user grows list grows infinitely. That's not great. It's not a great sentence. List views builder's factory constructor allows you to build list views lazily on demand. Add a suggestion list to the random state list class for saving suggested word pairings. Also add a bigger font variable to make the font size larger. They're going to get rid of my cute little text style. Okay. So grab that, put that into the state object. So there we go. Final. It's always good. They're grayed out at the moment. They're not being utilized. Next, you'll add a build suggestion function method to the random word state class. This method builds the list view that displays the suggested word pairing. The list view class provides a builder property, item builder. That's a factory builder and callback function specified as an anonymous function. Two parameters are passed to the function, the build context and the row iterator. The iterator begins at 0 and increments each time the function is called. It increments twice for every suggested word pairing, once for the list tile and once for the divider. This method allows the suggested list to continue growing as the user scrolls. Add a build suggestions function to the random word state class. Okay, I'm going to copy that. So within this class, we introduce another function. There it is. It2 is not being used, so it's grayed out. And it's numbered. So we're going to talk about the item builder name parameter. The item builder callback is called once per suggested word pairing and places each suggestion into a list tile row. For even rows, the function adds a list tile row for the word pairing. For odd rows, the function adds a divider widget to visually separate the entries. Note the divider might be difficult to see in smaller devices. Then in number 2, add a 1 pixel high divider widget before each row in the list view. Here we are. This item 3, the expression iterator tilde /2 divides I by 2 and returns the integer value. Alright, so it doesn't return any decimal places. This calculates the actual number of word pairings in the list view minus the divider widgets. 4, if you've reached the end of the available word pairings, then generate 10 more and add them to the suggestions list. The build suggestions function calls build row once per word pair. This function displays each new pair in a list tile, which allows you to make the rows more attractive in the next step. Add the build row function to the random word state. So yet another function's going in. It's being called here, by the way. So when we introduce it, the name of it won't be gray because it'll be used. There we are. In the random word state class, update the build method to use build suggestions rather than directly calling the word generator library. Scaffold implements the basic material design visual layout. Replace the method body with the highlighted code. Okay, so replace the whole thing within that build. I could just copy the whole thing, but let's just emphasize the fact that this is all going away within here. New scaffold. So we're going to have 2 scaffolds in this sample at the moment. Oh no, they want you to remove it. Well, watch this now. I'm just going to save it for now and show you. See now, there's 2 scaffolds. But in the next step, they're actually going to remove this one. And there's the list. Look at that. So let's go here. It's all gone. All in red is removed and all in green stays in its place. So now the material app widget just takes two parameters, title and home. So go all the way back up here. Within this function call, we're just going to get rid of everything, replace it with this, reformat, and there we are. So if I save this now, there we have it. So, and it's producing 10 more entries every time we scroll. Restart the app, you should see a list of word pairings no matter how far you scroll. Okay, if the app is not running correctly, again, they provide you with source code. What's this part now near the end? Profile or release runs. Do not test the performance of your app with debug or hot reload enabled. Of course, that will impede its performances. So far, you've been running your app in debug mode. Debug mode trades performance for useful developer features such as hot reload and step debugging. It is not unexpected to see slow performance and janky animations, of course. We've read all this before. Once you're ready to analyze performance and release your app, you'll want to use Flutter's profile or release build modes. Okay, so let's go on here. Congratulations. You've written an interactive Flutter app that runs on both iOS and Android. In this code lab, you've created a Flutter app from the ground up, written Dart code, leveraged an external third-party library, in other words, utilized a third-party library, used hot reload for a faster development cycle, implemented a stateful widget, created a lazily loaded infinite scrolling list. If you would like to extend this app, proceed to part 2, in which we will. And we'll do that another time. But for now, there you are.